How to compute for probability. This is the second video on basic probability. So what is our understanding of probability? What comes into your mind when you think about probabilities? Probabilities are associated with chances, the chances of an event happening, the likelihood of an event happening, the odds. What are the odds that something is going to happen? Okay, so it's another way of saying the odds are, or it's very likely that. So these things are what we associate with the idea of probability. But what is so fantastic about probability is, believe it or not, you can assign it a number. Okay? You can assign it a number. So a probability is a function p that assigns to an event A a real number p of A, such that p of A is less than or equal to 1, but greater than or equal to 0. When p of A is equal to 1, that means A is sure to happen. Event A is a sure event. It is going to happen. When p of A is equal to 0, that means A is not going to happen. A is an impossible event. So you can look at the function that assigns a real number to an event in this way, okay? So we have a line segment. At one end we have 0, at another end we have 1, and then in the middle is 0.5. P of A, the probability that event A is going to take place, is equal to a real number in this interval. When P of A is equal to 1, then it is a sure event. When we say that something is 50-50, what we mean is the probability that that event is going to happen is 0.5. It's halfway between an impossible event and a sure event. So these are the latest stats I got from a website that is monitoring the cases of coronavirus infection, the deaths, and many more. Let A be the event of dying from COVID-19 given that a person is infected by COVID-19 virus. Okay, so we are talking here about probability, and believe it or not, we can give a number to this, okay? And it is in fact equal to, okay, so A is the event that a person will die given that he or she has been infected by the COVID-19 virus. So what is P of A? Well, it turns out it is equal to this. It is equal to 0.017, okay, rounded to the nearest thousandths digit. Or in layman's language, most people are not comfortable with describing the probability in terms of decimal numbers. They prefer it to be given in percentage, or in percent, I mean. So the probability that a person will die from COVID-19 given that he or she had been infected is 0.017 or 1.7%. And where did that come from? Okay, where did that come from? Okay, actually it came from this. This is like the size of the sample space. Okay, I spoke about sample space before. Okay, so we have such thing as a size of the sample space, the number of elements that is contained in the sample space. So we can look at the total number of coronavirus cases as the size of the sample space, or the sample space itself. And there are 892,880 coronavirus cases in our country, by the way. Now, of those 892,880, how many people died? This is the number of people who had died, 15,447. And so the P of A that you are seeing here, P of A, the probability that someone will die from COVID-19 infection, given that he or she had it, is equal to 0.017. This came from this. 15,447 divided by 892,880. Okay, so that is where these numbers came from. Now, how about this? Okay, this is not A. The probability that a person who had been infected by COVID-19 virus will not die. Okay, and what is that equal to? It is equal to 0.983. 0.983 or 98.3%. So it's close to 99%. So what that means is even if you had been infected by COVID-19 virus, the probability that you will not die is in fact very high. You will not die. Well, that is not a sure event. But look at this. This is close to 1. This is close to 1. This is close to 100%. So it is close to being a sure event. You will not die. And that's why I hope that I can persuade you to believe and to believe, okay? And to accept that COVID-19 infection is not a death sentence. It is not a death sentence. Look at the numbers. Look at these numbers. The probability that someone will die given that she or he had contracted the virus is 1.7%. But the probability that he or she will not die, okay, look at this, look at that, that's 98.3%. It's almost like a sure event. These numbers will change when we talk about different samples. When we are narrowing our attention to a specific segment of the population who had been infected by COVID-19. Okay, look at this. The odds ratio of death for a patient with a comorbidity compared to one with no comorbidity is 2.4. So what are the comorbidities are we talking about here? These are like pre-existing health issues like hypertension, heart disease, and diabetes. So if you had been infected by COVID-19 and you have this, then the probability that you will die is doubled, okay? Because if the odds are the same, then the probability of someone who has a health issue divided by the probability of someone who has no health issues is going to be 1 because they are the same. But look at this. The odds ratio is 2.4. So it becomes double. If you have this hypertension, heart disease, diabetes, your probability of dying if you had been infected by the virus is doubled. It's no longer 1.7%. It becomes, okay, or what's the double of 1.7? It's something like 3.4%. Okay? But that is based on our stats. Okay, the stats coming from our country. This one came from the World Health Organization. Okay. Okay, so let us define some terms. Outcome. It's the result of an experiment. Sample space. The set of all possible outcomes. An event is a subset of your sample space. A simple event is an event that has only one outcome. Okay, we will see more of these terms when we go to computing for probability. So how do you compute for the probability of an event? Given a sample space where all outcomes are equally likely, if A is an event, the probability that A will happen is equal to this, the frequency of A, divided by n, where n is this the size of the sample space. The frequency of A is how often do you see A in the sample space. P of A is equal to, again, the frequency of A, how often you see A in the sample space divided by the size of the sample space. For example, our experiment is rolling a 6-sided die. These are the outcomes. So this is the sample space. Capital N, the size of the sample space is 6. What is P of 1? What is the probability that when you roll a die once, what's going to appear is the number 1? Well, How often do you see 1 as an event in the sample space? It only happens once. So, P of A, the event that 1 is what will appear, is going to be 1 divided by 6. The frequency of A divided by the size of the sample space. How about this? A is the event when the number that appears is greater than 2. So what are those numbers? 3, 4, 5, 6. So that is how often you are seeing a number in the sample space that is greater than 2. So what is P of A, where A is greater than 2? So this is like, what is the probability that in a roll of a die, of a 6-sided die, what you will get is a number that is greater than 2. So it is equal to 4 over 6. 1, 2, 3, 4 divided by 6, the size of the sample space. A bag contains golf balls. There are 50 of them in the bag. 20 are white, 10 are neon green, 15 are yellow, and 5 are bright orange. Let A be the event that a yellow golf ball is drawn from the bag. Let B be the event a white golf ball is drawn from the bag. And let C be the event a black golf ball is drawn from the bag. What is P of A? What is the probability that when you draw a ball from that bag, what you will get is a yellow golf ball? So again, this is P of A is equal to how often do you see A in the sample space? Or how many A's are there in the sample space? Divided by the size of the sample space. We have 15 yellow golf balls. So N of A is 15. The size of our sample space is 50. And so P of A is equal to 15 divided by 50. We have a common factor. The common factor is 5. 5 divided by 5 is 1. And so we are left here with 3 over 10. P of A is equal to 3 over 10. How about this? Let B be the event a white golf ball is drawn from the bag. What is P of B? P of B is equal to N of B divided by capital N. How often do you see a white ball in the sample space? It's 20. And the size of the sample space is 50. So P of B is equal to 20 over 50 or 2 over 5. How about this? Let C be the event a black golf ball is drawn from the bag. Find P of C. P of C is equal to how often do you see a black ball in the bag? Well, you have no black ball in the bag. So it's 0. 0 over 50, which is equal to 0. So the probability of getting a black ball from this bag is 0. It is an impossible event because you have no black balls in the bag. Let D be the event a white ball is not drawn. Okay, so we are kind of rephrasing the question here differently. Okay, find P of D. P of D is equal to N of D divided by capital N. Let us look at the sample space. How many events are there in the sample space in which the color is not white? You have 30. Okay, 30 of the outcomes in the sample space are events when the color of the ball is not white. 10 plus 15 plus 5, that's 30. So P of D is equal to 30 over 50 or it's equal to 3 over 5. That is the probability that the ball that you will get from the bag is not white.